To everybody who's joined us today for our OWASP Los Angeles monthly meeting. I'm Richard Greenberg, head of the local chapter here in Los Angeles. I'm also on the OWASP Global Board of Directors, and it's my great privilege and a pleasure to MC these events. We've got a special guest today. Clint Gibler will be joining us shortly. I just wanted to take a few minutes to tell you guys a little bit about what we do here in Los Angeles. We've crossed the 2,000 meetup number, which is a good number of folks. We are in one of the largest megalopolises in the world, so we'd love to have more, so spread the word. Those of you who have heard of AppSec California, we're one of the original host chapters. It's a great community, great peer networking, great in-person meetings once that can restart again. But for now, we'll be happy to have virtual meetings. It does give us the opportunity to have folks who might not be able to travel to get here and also to view the speakers. So there are pluses to that as well. But there's nothing like that in person, you know, those little meetings that we have off to the side at all of our meetings. So once this ends, hopefully you can join some of the 70 to 90 people that typically come to our meetings. I want to give a shout out to our board of directors. These folks have worked tirelessly to help bring you great speakers, great events, some great training, and just to be proselytize the OWASP organization and the tools and techniques and templates that are out there. You know, I just want to give them a shout out again. It takes a lot of work, and it's all volunteer work. Those of you who are looking for our next meeting as well, not to get ahead of ourselves, but we're really happy to have Christian Brand who will be joining us. He'll be talking about how to FIDO. So please mark your calendars. If you are on this meeting but have not signed up on Meetup, please do, so you'll get notification and how to sign up for our meeting moving forward and be part of our community. Speaking of community, there are several ways you can connect with us. We even have Instagram, even though I'm too old to use it, but my daughter makes sure I stay on that. So please do join us on all these different social media platforms and share your ideas. We try to put relevant information on there, and we'd love to hear from you as well. So please do use that as an area where you can share or comment on some of our posts. There are sponsorship opportunities though. If you work for a company that's looking to get your name more recognized and potentially meet some new partners in the business world, new customers, please look us up, and your name could be on these slides as a thank you. And also you'll be linked at our emails that get sent out. So we have to have vendor and client relationship that all of us do, very important moving forward. And we appreciate the efforts that are done on the behalf of the vendors. So consider it. We're all home. Our commute has dramatically reduced for many of us. Those of you who have to go into the office, please be careful. But I'm sure your commutes are much more enjoyable now than they used to be. But while you're home with that extra time, you might want to catch up on some of the talks we've had at AppSec California. The most recent was this past January, kind of got in under the wire. That was very fortunate timing. And it was an amazing conference, it really was. I believe that Clint might have spoken at this past January as well, so you can see a different talk from him there. But also we have all our other years. We made it a point to videotape every single year of AppSec California, and we're at 7 years now. So lots of great content. Come to our YouTube channel, and I hope that you can get a lot of great value out of those slides and presentations. And that's the reason why we did that. We wanted everyone to learn and to share. I wanted to now, the moment you've all been waiting for, to introduce the famous Clint Gibler. He's the head of security research for R2C. It's a small startup working on giving security tools directly to developers. Previously, he was a research director at NCC Group. You've heard of them, no doubt. They're a global security consulting firm, and he helped companies implement security automation and DevSecOps. I'm glad you have that sec in there. Best practices, as well as perform penetration tests for companies, ranging from large enterprises to new startups. He's also spoken at conferences including Black Hat USA, AppSec USA, AppSec Cali, yeah, and AppSec EU. He's a great proponent. B-side San Francisco, DevSecCon, Seattle, London, Tel Aviv, Singapore. He's a world traveler. He's a PhD in computer science from the University of California, Davis. And with that, I'd like to hand it over to Clint, and we're really happy to have you. And personally, as a friend, I'm really excited to hear what you've got to share with us.
Yeah, thanks so much, Richard, and thanks for having me. I'm a huge fan of AppSec Cali. I think I've been every year for the past 3 or 4 years, and I frequently tell people it's my favorite conference. That and besides SF, I think are the right quality of people and also sort of nice and approachable and great content. So yeah, I'm super excited to be here. Yeah, so today I just wanted to tell you a little bit about an open source tool we've been building called SemGrep. And basically the idea is like, how do we make it easy and fast to find interesting code, whether that's vulnerabilities or anti-patterns or things like that. Yeah, so all the slides are going to be made available after this. And if you have any questions, feel free to ask at any time. Feel free to stop me. This is meant to be very interactive. And yeah, very much looking forward to chatting. So if I'd known Richard was going to read my entire bio, I would have sent him a much smaller one, probably just like one sentence. But yeah, this is me. Currently at R2C. Before this, I was currently R2C, previously NCC, and before that, a indentured servant, a grad student at UC Davis, where I tended to dress like that. And yeah, we're a small static analysis startup based out of SF, looking for building tools that are usable and help people get their jobs done better and faster. So I like to boil things down to, this whole talk, what is it in sort of one slide? And the core idea is SemGrep is an open source, very customizable and lightweight tool for finding bugs. It's batteries included, so there's hundreds of existing community rules written by us and other bug bounty researchers and other members of the community. And the idea, I think what makes SemGrep is uniquely powerful and interesting is that it's combining the things we like about grep, so the speed and the ease of customization, with the expressiveness and the power of sort of traditional commercial static analysis tools. So it's this nice middle ground, and we'll talk about that a little more in a second. So it runs offline on uncompiled code. You don't need to integrate into the build environment, and it's fast and open source. And we're going to walk through a couple of examples, but you don't need to learn a fancy, complicated domain-specific language. The patterns that you write look pretty much like the source code you're targeting. So I think that's pretty exciting. So it's on GitHub, LGPL licensed, and we currently support Python, JavaScript, Golang, Java, C, JSON, Ruby just landed, and I think OCaml did as well, with more languages always being added. Okay, so at a high level, we're going to talk about a couple of different things. So one is just some background, like where does SemGrep fit into the broader picture of static analysis? Then most of the talk is going to be on a hands-on demo where we're going to show like this is what writing patterns look like. We'll talk a little bit about the registry. So what are all the rules people have already written? What do you get out of the box? And then lastly, we'll touch a little bit on integrations, like how do I put this into CI/CD and other sort of ecosystem type stuff like that. So, okay, so let's talk about some background. So let's say you are a security person auditing a code base and you want to say, hey, I want to find calls to a dangerous function, let's say exec, which like exec and eval and things like that. If an attacker is able to provide input into it, they can run arbitrary code. So this is very dangerous. So let's say, like, how would we find this with grep, which is a nice way to sort of quickly search through source code using regular expressions. So like this first example, like this is pretty easy. We might just say like exec and then open paren. And the second example is also pretty easy. But then we can see there's a couple of other examples where things start getting a little more frustrating, right? So like there could be some extra white space. Maybe there's new lines. So like our regex would have to get a bit more complicated to handle those. This case is kind of hard, right? Because like exec open parentheses would match this, but exec isn't actually the function name, it's a different one. It just ends with the pattern we're looking for. And then some cases that are perhaps even harder, this isn't a comment, this isn't a string literal, like there's a lot of things that are making this pretty hard. We really want something more expressive than grep. Obviously, there needs to be an obligatory XKCD for everything. Just highlighting regular expressions are very powerful and they're good for a lot of cases, but some, they can be not quite the right fit for the problem. And I think sort of the core insight here is that source code is not just a string, right? It's not just sort of this flat text that has no meaning. Like every statement has a meaning, right? It's like, this is a method definition, this is a function call, this is a variable assignment, things like that. Like really the way compilers and interpreters see code is a tree, not a string like grep sees it. So our idea is like, how can we make it easy to find these interesting code patterns in like a language-aware way, but also that's easy to use. So we're not the first people to think this is a great idea. There's a lot of tools out there that use abstract syntax tree matching. For example, Bandit, dlint, ESLint, Flake8, and a bunch of other tools. So these tools are great. They are much more precise than grep, but the challenge is each one of them represents this internal source code structure in a different way. So if in your company you have, say, 3, 5, 7 different languages in use, you have to become like an expert in how each of these tools work. And also it's not necessarily easy to express like in each tool, like how do I match this specific pattern that I'm looking for? And on the other end, there are commercial static analysis tools, but these tend to also be very complicated to customize. They're often very slow and difficult to put into CI, and they're also very expensive. So just an idea of the sort of complexity of writing tree visitor patterns in these other tools. I copied a screenshot of ESLint's check for banning calls to eval on the right-hand side. And there is some like comments and boilerplate, but the whole thing is like 307 lines of code, which is a lot, right, to just match like this is a function call. So we're going to show how to do that a little bit more easily and concisely using semgrep. So Benjamin Woodruff from Instagram wrote this blog post that we thought was really nice, where they sort of present static analysis as a spectrum, where on one side you have regexes that are very easy but kind of dumb. They're not aware of the source code. And then on the other side, you have this whole program analysis where you're reasoning about control and data flow across many files, and sort of very heavyweight and slow but very powerful. And then in the middle, you have this abstract syntax tree sort of linters. And semgrep basically fits right in the middle. So for your mental model of like, how does everything fit together, I think this is a nice summary. OK, great. So let's get into demos, because I think that's the fun and interesting part. So basically, when you write semgrep patterns, you're writing the source code you're targeting. It looks very similar. There's not a different DSL you have to learn. And there's basically 2 different operators that are sort of abstractions built on top of that. And we'll go through those first, so this ellipsis and meta variables. And then we'll talk about using semgrep for a number of other use cases and some advanced features. So, OK, so let's look at this first sort of simple exec example. So semgrep is on GitHub. You can download it as a standalone binary or run it via Docker or things like that. But for this talk, just to make things nice and easy, we're going to use semgrep.live, which lets you basically run semgrep in your browser. So you don't need to install anything. You just copy some code in here that you want to match. You select what language is it, and then you write whatever pattern you want in here. And then when you click run, it shows you the results on the right-hand side. So just sort of nice and easy. But again, if you want to do this via CLI, you can do that too. So this is the case we talked about before. We want to match all calls to exec. So what we can do here, and we've been actually building this recently, because sometimes writing your first pattern is hard, so we want to make it as easy as possible. So we actually have this functionality for, in some cases, you can actually generate a suggested pattern, which gives you like, oh, here are some things that you could do. And we'll talk about more about these in a second, but let's say that we just wanted to do the sort of exact match. So here, we're only matching one thing because the function name needs to be exec, and the argument needs to be some var. But this is not exactly what we want, because really we want to match calls to exec with any argument. So the first feature, the ellipsis operator that SemGrep provides, is basically like when you don't care what's in the middle, whether it's a set of statements or a number of arguments, if you want to say there can be 0 or more of these, just replace whatever it is with ... and then run it, and then cool. So we've matched exec with a hard-coded string as well as a variable, and white space doesn't matter. So also what's great is we did not match other exec, which is a different function name. We did not match a string, and then a comment we also didn't match. So basically in about 6 or 7 characters, we are more precise than a very long, complicated regex, and we didn't need to write a 300-line ESLint rule or whatever the AST matching tool is. It's just trying to match like what we are conceptually thinking in our head we want to find. So SemGrep actually has a number of powerful features that enable you to match what you're intending to do without you needing to write in more complicated logic. So let's look at an example. So you could imagine in code, like sometimes there's import aliasing where something has a different name locally. So what if the developer said like, okay, let's import exec as a safe function. So within the scope of this file, you can refer to exec as the name safe function. And then let's say the developer were then to say safe function user input. So here, exec is being called, but it doesn't look like it because it has a different name. So grep would never find this. But with SemGrep, we're actually tracking aliasing of imports. So we know that within this scope, safe function actually refers to the thing we're searching for. So note that our pattern didn't actually change. Like the person writing like this is the thing I care about didn't have to do anything smart to be able to, or anything complicated in the pattern to find this case that is maybe non-obvious if you don't think about it. Okay, so this is a simple example of the ellipsis operator where you're like, match any function called exec, and I don't care about the arguments. Cool, so let's go to the next example. So here, another thing you might often want to do is matching hard-coded secrets or constant string arguments. So let's look at this. So basically what we have here is there's this AWS Boto 3 client, which has 2 keyword parameters. So AWS access key ID and secret access key. So here it's just hard-coded strings. Here it's some constants that are then passed in later. So, as security professionals, we might want to say, oh, I want to find all hard-coded secrets because if my source code were leaked, someone could, spin up a bunch of new instances or gain privileged access to my environment. So we want to find hard-coded secrets. So basically what we can do is say, copy this stuff up here and say, this is actually Boto 3, is the full path. We don't care what the first argument is. So let's just say ... We don't care what the value of this is. So by having ... in quotes, we're saying like, oh, match any string and I don't care what the value is. And then let's do the same for here. So basically what we're saying is I want to find all calls to boto3.client. I don't care about, there can be 0 or more arguments here, but I want to know when it has these AWS access key ID and access key that are hard-coded strings. So here we see it matched this, even though the direct arguments weren't hard-coded strings, but we can see that these are constants that are passed in. And the second case is actually pretty interesting because notice how up here we have access key ID and then secret access key. But here the order is actually reversed. It's secret access key and then access key ID. So even though the order in the pattern is different than the order in the source code that we matched, SemGrep knows that the order of keyword dict arguments doesn't matter. Like semantically, these are equivalent in Python. So without coding anything extra fancy, it just works. Yeah. So let's check out the next part. So let's So that was the ellipsis operator. Let's talk about meta variables a little bit. So meta variables are basically like, I don't know what this is, but I want to capture it, or I want to reference it later. So it's kind of like capture groups in regular expressions. So let's say we want to match all comparisons. So we could basically say $X. So a meta variable is basically $, and then any alpha string. So we could say something is getting compared to something else. And I don't necessarily know what the left or the right-hand side are, but I just want to match them and sort of be able to reference them later. So cool. We can see that we match these calls in comparing integers, comparing strings. Like, this is pretty complicated, right? A.id and then string, of len of array. But because both sides are the same, because this is a comparison, it doesn't matter that these are very complicated expressions. The meta variable like matches the whole thing. And we can see in this list comprehension, because it's a double equal sign, we're matching that too. So one thing that's nice is within one pattern, meta variables are enforced to be the same. So instead of x is equal to y, which is two different things, if we were to say x is equal to x, this is only going to match comparisons where the left and the right-hand side are the same. So if we do that, we can see that indeed 5 is the same as 5. These are different, so it doesn't match. Strings are the same. Even complicated expressions, when they're the same, still match. And then here, this is actually an interesting case because it's actually based on a real bug we found in a popular Apache project where a developer had a node ID argument to the function, but in the comprehension, they actually used x.nodeID instead of this node ID. So this is always going to return true because something is always equal to itself. Yeah, so let's see, I don't know if feel free to stop me at any time with questions because I'm sure if you have a question, other people do as well. So I don't know if there's like an easy way for me to bring up the little question thing.
Yeah, Clint, actually, I can read it out for you if you like.
Oh, that'd be great. Yeah, thanks so much.
Yeah, no worries. So the first question we have is there a reason you don't support .NET?
Oh, yeah. So the answer is because we are doing, because each language, when you write patterns, like we need to be able to parse and do some fancy things with that language, we have to add support per language, unlike grep, which can process anything. So .NET is actually high on our list. Probably in the next couple of months, we'll add support for a couple of .NET languages. A number of companies have been asking us for C# specifically. Yeah, so it's basically we just haven't gotten there yet, but we will.
Gotcha. Okay, second question I have is, does it handle macros in C?
Yeah, that's a great question. So the answer is currently no. Because we would have to do some like macro expansion and things like that. So actually the background of this tool, it was originally created at Facebook a number of years ago by someone called Yoan Padalu, who did his PhD at INRIA, and a tool they were working on, CoxML, was actually for large-scale editing and refactoring of the Linux kernel, which is C. So he has a lot of experience with that, and we have initially some C support for like basic type of rules, but we haven't got asked as much about handling C in general, so we haven't focused on being able to handle things like macros, poundefs, and things like that. So if it were to be very important to a number of people, we would certainly consider it, but it hasn't been the biggest asks we've had so far.
Awesome. Looks like one more question.
Yeah, great. Thank you.
Yeah, no worries. Does semgrep live capture all the code, and how secure is it to use?
Yeah, that's a good question. Let's see. So we do capture crashes and different things like that, or like errors and when people are having trouble, so we can try to help them. Honestly, I am not sure if we store everything. So we do have a functionality where you can create like, hey, like give me a permalink to this, where if you're like, hey friend, I'm like working on a thing, like does this, like let's work on this is an anti-pattern for our code, this is my attempt, what do you think, and you sort of work on it together. So we use this share feature, which gives you sort of like a permanent thing you can go back to. So in those cases we definitely do. In the general case when you don't store it, to be honest, I'm not sure. But you can run this just locally via CLI or Docker. So like you don't need to run it in the browser. This is just sort of easy for demo purposes. Yeah, and so the short answer is I'm not totally sure, but if you want to use the live editor, I would encourage you to, and it was very sensitive, you could create sort of like a minimal anonymized version of the code if you're very sensitive about it, or just run it via CLI if you want sort of like maximal assurance.
Cool.
Cool. Yeah, thanks for the questions. Okay, so let's get into a little bit more of a direct security example. Oh. Let's see. Okay, great. So let's say we have a Flask application that is defining a route here, and then basically it's taking a file name, it prints that file name, and then sends that file name back. So this could potentially be dangerous because if an attacker were to provide like // you could maybe extract like etc password or maybe environment variable files or things like that. So we might want to say, let's find cases like this. So basically what we can do is copy the target up here and then say, well, like this path doesn't necessarily matter. This method name probably doesn't really matter. See the arguments. You know, it could be named anything. This print doesn't really matter. So let's just say ... But what we do care about here is we want like this argument, which is the user provided input. We want to see if that is going to the send file. So for that, if we use file name again, which is the same meta variable we set up here. So basically this is like some method, we don't know what it's called, is taking this argument, and that argument is eventually getting passed to send file. Oh, I think this might need to be flask.send file. Yeah. So one sort of gotcha is SimGrep resolves like what is the full sort of canonical path of methods. So sometimes you need to include those in the pattern. So you know here, because it was imported locally and then just use here, but so that's why I needed to make that update. Yeah, but one thing that's nice about this is basically we looked at some code that we wanted to find, we copied it up here, deleted a few things, made a few things more generic, and then basically we're done. Okay, great. Any additional questions so far?
Yeah, it looks like there's one question about using wildcard files, or can you wildcard files or different types of files? I'm assuming is the question.
Yeah.
Not sure what the.
Let's see, wildcard files. Yeah, can whoever asked to provide a little bit more details or examples? I'm not totally sure I understand the question. Like maybe I want to match some specific path, or
well, I do a lot of kernel maintenance, and you have different files and libraries, and some of them written in C, and some of them written in that bastard language C++, unfortunately. Some of them have old macros in them. And so when I'm searching, and this all applies in any open source project, I'm looking for different, sometimes I'm not just looking for .c files, sometimes it's .c files, Java files, whatever. And I'm looking for patterns that might exist in a bunch of different kinds of files. Did that sort of make sense?
Yeah, definitely. So, so far we've been doing single patterns, which is just sort of like this simpler, easier to get started way. But we'll look into more of this in a second. But there's also a way to specify more complicated things in this YAML syntax, which we'll look at some examples. But basically, it allows you to compose patterns where you can say this and not that, or this and that, or either of these may match. But we'll talk about that in a second. But one of the things to your question, you can also have like a languages key where you could say like C, Python, whatever. So you could list like these, for this rule, these are the languages that I expect it to run on. So you definitely can do that. You can also say like match these paths or ignore these paths, or I care about this file extension. There are a bunch of things like that you can do as well. I would say one thing though is as you write more specific patterns, they might not necessarily be valid in multiple languages because they may rely on like a specific API call or something that is maybe not present in multiple languages.
Okay.
But
because the use case, and this applies to Android as well as Linux, is you've got an application that has a Java interface, and it goes to JNI, and then eventually it gets down to a library, and that library is calling something in the kernel, and you're wondering why it's doing this. And so the usual thing in grep is you have to look in all of those layers for instances of that function call or some variation of that function call. And it's time consuming. This is a fantastic utility, by the way. It'll save
thank you so much.
tons of hours of work. I'm just excited about it.
Yeah, these are great questions. Yeah, let's like come back to that more in a second, maybe towards the end. But I will say that like semgrep is made to be very like lightweight and composable and scriptable. And so it can output just standard out, or it can actually output to JSON. So, and the things that you match in here are included in the JSON output to say like, oh, this meta variable matched this exact text. So we've actually built some custom scripts to say like, just like 100 lines of Python that's like, okay, run semgrep to first find, say like all of the routes, or like basically like say external attack surface. And then using that input, like, so the Python calls semgrep, it gets the response, and then it like parses that response to say, oh, given this data, then run another semgrep query, which then sort of to your point of like, oh, this Java is calling JNI stuff. So maybe the first semgrep call is like, here's all the places JNI is being called, and these are the methods that I care about. And then you sort of like dynamically construct a second query, which then looks for all of those things.
This is truly awesome because you know, I'm used to command line stuff. As you already know, you get a bunch of command line stuff and you put it in a bash loop and blah, 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 you know, where all that goes. And so this is entirely a Python program. It doesn't have any dependencies outside of Python.
Yeah, so there's basically two parts to semgrep. So there's a there's an OCaml core that does a lot of the fancy program analysis stuff. Because you just sort of need some of that power. Lots of the programming language research interesting is in OCaml.
You use OCaml. That's so cool.
Yeah, so
I didn't know anybody knew what that was anymore.
Yeah, it's in use by us, I think. Yeah, so the core, and there's a bunch of like sub-libraries for this, but so basically the core doing the fancy program analysis stuff is OCaml, and then there's like a scripting Python layer on top that does the sort of like YAML syntax and like composing patterns and sort of the higher level CLI type stuff. But the workhorse of this, and it's actually more OCaml than just this because there's other repos that are not shown here that are sort of used by this. But yeah, so it's basically OCaml and Python on top, which gets compiled to a standalone binary or a Docker. But cool, yeah. Thanks for all the questions. Yeah, I think at the end or maybe after this, we have some cool stuff to nerd out about, which I'm excited for.
Sweet utility, very sweet.
Yeah, thank you. Any other questions I can address before we go on? Cool. So we've shown some sort of basic examples. But obviously we want to turn it up to 11. So I want to show some other cases that are not just finding security bugs, because I think these are interesting. So one is like, how do we find like business logic flaws? So you can imagine you might have a financial trading application where, or just anything, where it's like this API call must be called before this other one. So in this case, like verify transaction must be called before make transaction, so that if that doesn't happen, it's a bug. So let's look at that for a second. And actually, maybe for time, let's so we can see more examples. Let's just sort of cut to the chase. So basically, to check this idea, so here's some test cases. Like this is okay because verify is called first, but if verify is not called first, that's bad. If they're called in the wrong order, that's bad. If you just call verify, that's fine. And maybe there's other statements in the middle. So let's look at how you would express this in SemGrep. So what's kind of nice is this is basically, the pattern is basically what you would verbally describe it. So like, again, we're using this multi-pattern syntax, which allows us to compose patterns. And we're saying, okay, this is what we want to find. If there's a method, we don't care what the name is. We don't care what the return type is. Other statements may be there, but any method that calls make transaction is potentially a bug. But we know that it's not a bug if verify is called before make transaction. So conceptually, we sort of took like the specification we had here, translated it into pseudocode, and then when we run it, we can see that it found the cases we wanted to find and did not find the cases that we do not care about. But there's actually this case at the end that's pretty interesting, where we are calling verify before make, but we're actually passing in the wrong argument. So the transaction that was verified is not the transaction that was made. So this could be a bug. So what we want to do, and we can actually use meta variables for this, is enforce that these are the same. So the argument that's passed to verify must be the same as what's passed to make. So with this small change, we can see that we are flagging this last case. So again, this is like not necessarily like cross-site scripting or SQL injection, but it is like a perhaps a business logic bug. And every code base has its own expectations about what is called when and in what order. And SemGrep ideally lets you sort of express this domain knowledge simply and concisely, so that, you know, when new developers are onboarding, you can just say, hey, you know, just SemGrep runs on every, say, pull request, and you don't necessarily need to read this massive document on like, here's how we code. This is just like, here's the gotchas sort of thing. So we found some development teams finding SemGrep very useful as well, not just security teams. Yeah, any questions about this one?
Hey, Clint, this is Anil again. I just had a unrelated question, kind of, not
sure.
related to this particularly, but I noticed that there are community rules and you can kind of write your own rules.
Yep.
So if I was to just go through the process of writing my own rule, I could then contribute to the community by, you know, providing that as a community rule, or how does that work?
Yeah, that would be awesome. Yeah, so I'm gonna show you this later. But yeah.
Oh, sorry.
Yeah, no. Yeah, how about I'll give you like maybe a quick answer now and then a longer answer soon.
Perfect. Yeah.
But yeah, the answer is totally. Yeah, we would love contributions. A number of security researchers as well as like developers and other people have contributed rules. And we have this open source SemGrep rules repo where rules from us as well as the community live. We have like a fledgling project to maybe create some rules around OWASP ASVS, which I can maybe talk about later. But yeah, basically, if you were to create some things, we would love to have them, and you could just put them here, and then other people could benefit from them, which would be awesome.
Nice. Thank you.
Yeah, no problem. Okay, so another thing is, again, this is not necessarily a bug, but maybe we want some visibility. Like, when is someone adding a new route to our application? So just like skip to the chase. But basically what we could say is, hey, anytime we're inside this controller object, we want to match, like we know that it's a route if it has this request mapping, and using meta variables, we pull out the HTTP method. Does it have some sort of authorization being done? And maybe the method name. And I think I may have mentioned this before, but just sort of to be clear, these, the meta variables that you match are both returned in the JSON as well as in the message. So if we run this, we can see that we're pulling out the name of each of the method, the path, if it's present, the request method, so get or post, and then the authorization being enforced. So we've actually used this to audit large code bases that have hundreds of routes to see, oh, are you applying authorization checks consistently? Which are the routes that don't require that don't enforce any auth checks at all? Like maybe these unauthenticated routes are interesting. And the idea is like, you can use SemGrep to find interesting code patterns that are security relevant, but not necessarily a bug. Like maybe you want a Slack integration that says, hey, this repo just published a new code that introduced some new routes. So maybe we want to audit those. So I think that this is a very exciting use case for SemGrep as well. And honestly, the first version of this, when I was just joining R2C, I wrote in like half an hour. Because like, it's not too complex. You just sort of look at what you're trying to match, you like copy that up here, and then abstract a few things, and then you're boom, done. Yeah, so we've, again, talking to the scripting ability-ness of it, we've been building some things internally to say, so this is extracting routes from one of our applications. We sort of like built a tree and colored by like, oh, does this require auth or not? What's the request method and things like that. So, and I think that this was basically like 100 lines of Python wrapped around SemGrep with some route extraction rules. So not too complicated to write, actually. Okay, so we want to be a security tool that makes developers' lives easier, not just gives them more work. So one thing that's pretty interesting is you can not just say, here's a pattern that I want to fix, or sorry, that I want to find. You can also use this fix keyword to say, oh, whenever you find this, replace it with this. And so you can imagine like a comment on the GitHub or GitLab PR that says, hey, like we found this thing, here's an autofix. And if you click this autofix button, oh, by the way, this is in Golang, it's listening over HTTP, and ideally we want everything to be over TLS. So if we click this apply fix button, it rewrites it in place to say, hey, you should actually use listen and serve TLS, not just listen and serve. And it copies over the port that was used before, and then it adds in some additional arguments that, so the developer is going to have to do a little bit of work, like define where these are coming from, but perhaps you have some standard, like, oh, we always get this from Vault or environment variables, so you can add that to the description, which is shown to developers. So basically, we're trying to make developers able to push new code very quickly, but also securely. So we don't want to just flag things that are wrong. We want to give them as much information as possible about how to fix it. And ideally, they can just click a button, and at least in some cases, maybe upgrading deprecated APIs or things like that, they can just fix it and go about their business, working on the next thing. So yeah, any questions about this? Just do a couple of these. Okay, great. Yeah, I will move on, and feel free to interrupt me anytime. Okay, so let's discuss some advanced features. So, right, we're security professionals. One thing that we like is regexes. So if you already have a bunch of regexes that are looking for interesting things in code, you can actually just use pattern regex and include those directly. And basically use semgrep for everything, not just, and not have like a regex tool and then semgrep. You can actually just directly port those. But you can also combine semgrep's pattern matching with regexes as well, which we can see in this example. So basically, we are using semgrep to say, I want to match all calls to boto3.client. So it's going to match both of those. But we want to filter those to only matching the ones that match this regex. So here we're trying to match 192.168. So this would only match this internal network call rather than other ones. So you can use regexes either standalone or in combination with other semgrep features. Another example, so we've talked about semgrep being scriptable, but there's actually another feature that's pretty neat that we haven't even discussed yet called pattern-aware Python. So when we were building semgrep, we knew that there was going to be some functionality that users would want that we couldn't plan for, we couldn't foresee. So we wanted to make it nice and scriptable. So let's say, for example, this is Golang, where someone's calling RSA.generate key. And in general, RSA is fine, but not if they don't use enough bits of entropy. So here, like 1024, this is maybe not enough. We want to flag this, but 2048 or more, this is fine. So what we can do here is say, okay, I want to match the pattern, RSA.generate key, and we're grabbing whatever value is here with this meta variable bits. And then you can use pattern-aware Python, where basically any meta variable that is matched is passed into the environment to this arbitrary Python that you can run. And so what we can do is say, like, cast whatever the variable bits has in it to an int, and then if that's less than 2048, then match. So here, this would not flag this, or sorry, it would flag this, but not this, because it's not, because it is less than 2048. So we've written some rules where we are like importing other Python libraries to do other interesting things given the sort of meta variables that have matched. And obviously, we're very security conscious, so running arbitrary Python is dangerous. So it's very powerful, but also dangerous. So in order to do this, you have to pass in the flag, sort of taking inspiration from React, dangerously allow arbitrary code execution from rules. So basically, we didn't want to surprise anyone in terms of like, oh, this is potentially running untrusted code. So we just make people explicitly acknowledge, hey, I know that this is dangerous, but these are rules I trust. So I want the power that comes with this. Yeah, any questions about this one? Cool. Yeah, I'll keep going. We can always come back. So another thing you sometimes want to be able to do is match based on types. So for example, let's say here, this is Java. You want to match the exec calls on runtime objects, which is essentially shell execing command. So this is potentially dangerous, but an exec function call on another object maybe is fine. So here we can see we're passing in a runtime object as well as creating one. And when we call exec here, these are potentially dangerous. We want to find them. But here, this implementation, maybe it's just logging something. So this is fine and we don't care. So we can actually say, oh, this class meta variable needs to be of type runtime. This is sort of what the parentheses around it means. And then match calls to exec here. So this pattern would match these two because they're runtime objects, but not this one because it is a different type. So this allows you, again, to be a little bit more precise in your patterns. All right. Feel free to interrupt me, but I will continue. Yep, so pattern regex, already talked about it. So in security, oftentimes you want to do some taint analysis where you say this is a source of tainted user data. This is a sink, like this is a potentially unparameterized SQL query, or this is calling eval or exec. And we have initial support for taint analysis as well. So you could say, these are potentially user-controlled data. This is where it's potentially dangerous if it hits. And then these sanitizers are, if it goes through this, it's safe. So currently we're focusing on intra-procedural taint analysis rather than inter-procedural, so going across many functions and many files. And the reason for that is we want to be very fast. So we have to sort of limit our scope so that we can still process like tens of thousands of lines of code per second. And also, in many cases, doing interprocedural data flow analysis requires you to make assumptions that can make it a bit more imprecise, which leads to lots of false positives. And we would rather find things with very high signal rather than overburden security teams or developers with lots of noise they have to triage. But we are gradually making this better over time. So happy to hear your thoughts about this as well. So far we've been talking about source code, but we also, SemGrep also supports JSON. So say you're using infrastructure as code, like CloudFormation or something where you're specifying things in JSON. So here, this is maybe something you would want to find, and you could write a SemGrep pattern that looks like this. And this thing in the middle is basically a OCaml regular expression that's saying, I want to match strings that look like this. And you still have the power of the ... operator as well. So I would say our focus has mostly been on source code, but we are gradually adding support for like JSON and YAML and things like that. Okay, so we have a bunch of different operators. We've only touched on a few. So, you know, pattern either, which is like Boolean or regex, not, and so forth. So feel free to check out the docs for more details. Okay, so registry, what do I get out of the box per earlier question? So you can go to this semgrep.live/registry, which is basically a nice UI on top of the flat YAML files in this repo. And again, so we have hundreds of rules written by us in the community. The newest version of Node.js Scan, which is the preeminent Node.js security scanner, he actually came across SemGrep and then ported all of his rules to SemGrep because they were previously regexes. And he was like, oh, this allows me to be so much more precise, and I can write things that I couldn't write before. So basically from version 4 onward, SemGrep is actually the workhorse core engine of this other open source tool, which is really cool to see. And we wanted to test the sort of power and expressiveness of SemGrep. So we actually ported a number of security checks from other open source tools into SemGrep, so GoSec and FindSecBugs and so forth. And this actually only took like one security engineer a few days to port all of the rules from a tool. So I think that speaks to sort of the ease of rule writing. And also, unlike some other tools that require buildable source, SemGrep runs directly on source code, so you don't necessarily need to have a fully buildable environment. We've also worked with some of the people behind Django and Flask to write more tailored rules, and we have a couple of bug bounty security researchers using SemGrep to report bugs in Node.js and other type code bases across many open source projects. Yeah, actually, let me just show you that, because I think that it's nice to see what the registry actually looks like. Yeah, so basically, this repo of YAML files is pulled into this. So you can say, if you wanted to, like filter by language, you could look at, say, specific like categories. If you want to search for, show me all the JWT related issues, you can do that. We also have this idea of packs, which are basically custom groupings of rules that we put together just to make it easy. So here, these are all the rules we ported from Bandit and ESLint, security-related rules, FindSecBugs, GoSec, Node.js Scan, and more. And some of these are like, oh, I want to audit code, so I want to find everything, even if it's a little bit noisy. And this is more like, I want to put this in CI, so I only want like the things you're most sure about. So these are sort of nice ways to get started with some out-of-the-box rules. Okay, so let's talk about integrations. So again, SemGrep runs just via a command line standalone binary or Docker. So it's very easy to put into CI. You just, we have some instructions for GitHub, GitLab, and so forth. Outputs to JSON, pipe it wherever you want. So you don't have to run a separate server or do anything fancy. Yeah, any additional questions so far? Okay, great. Oh yeah, we can just quickly look at what this looks like in practice. So pretty standard. Basically, this is integrating as a GitHub action. We have a GitHub action you can just use. Pretty straightforward. So it looks like, just like, hey, I'm running. Here's a couple of things I flagged. You know, this is the line of code. This is the file. This is a message. And this is why it's an issue, and so forth. Sort of like the standard stuff you would expect. OK. So just a few quick wrapping up things, and then happy to answer questions after. So I said I'm a huge fan of AppSec-Cali, and that's true. So one thing I did last year was I decided to watch every single AppSec-Cali talk and write a detailed summary of each of them. It ended up taking me several hundred hours, so I'm not sure I would recommend it. But it was really cool to see the breadth and the quality of the different talks that were given. So if you want to go there, you can learn from my misery, or at least from what I learned. So you can just sort of read a quick summary of each of the talks. So I also have a newsletter that's like free, weekly, just like, hey, here's some new stuff in security. Here's some tools and resources you might like. There's at least one person who doesn't hate it, so maybe you'd like it too. Yeah, thank you very much for your time. Again, SemGrep is an open source code analysis tool that's easy and feels like grep. It's easy to match interesting code patterns. It's fast. It's maybe tens or even up to 100,000 lines of code per second. Handles a number of different languages. You can run it via semgrep.live or just Homebrew or Docker. And yeah, that's my social information. Feel free to reach out directly. There's R2C as well if you want to ask some grep questions to them. Oh yeah, so if you go to the slides, there's a few extra things that I'm not going to talk about now, but just like a recap of everything we discussed. Like, hey, here's some things that you can match. If you use this pattern, this is what it'll match. This is what the ellipsis operator does. Here's some like meta variable stuff. Yeah, so just wanted to let you know that if you go to the slides, which I believe should be linked in the chat, or I'll send a link afterwards. I wanted to make things nice and self-contained, so you don't have to like remember what I said later. But yeah, thanks so much for your time, and I'm happy to answer questions.
Thank you, Clint. That was actually really cool. I think this is a really cool tool to use, and I think a lot of people found a lot of value here. So thank you for your time.
Yeah, thanks so much. Yeah, thanks for all the good questions. Yeah, I'm thinking back to the, I think, Bill examples. Yeah, that sounds very interesting to me. Maybe we'll follow up later.
Sure. Richard, do you want to kind of take it from here?
All right, I wanted to thank you, Clint, and then I wanted to thank our audience for participating in this. This has been a good back and forth. Appreciate that. When that happens, that means the speaker is hitting on a really important issue and it's discussing a good solution. So thanks for doing that, Clint. And thanks for visiting us here in sunny California, Southern California.
My pleasure. Thanks for having me.
And thanks for the shout out for our AppSec-Cali work. You know, Clint's one of the planners for AppSec-Cali and has been for several years. And he's been instrumental in helping to make sure we have a great program. So shout out to you for that, Clint.
My pleasure.
Everyone, thanks for joining us. We do this on the 4th Wednesday of every month. Make sure you're with us on Meetup and our social medias. Presence is looking and waiting for you. And if you're interested in speaking, let us know. And let's hope that we all stay safe during these troubled times. And do appreciate, again, Clint coming by, and stay safe, my friend.
Yeah, stay safe. Hope to see you all soon.
Okay. Bye.